Welcome to Maths for You channel. Past questions on integrations from Oxford and Cambridge past paper show that 8 sine squared x cos squared x can be written as 1 minus cos 4x. Hence, find integral of sine squared x cos squared x with respect to x. Let's deal with that question. I just wrote it as fx equals 8 sine squared x cos squared x. That can be written as 2 times 4 sine squared x cos squared x. 4 sine squared x cos squared x is 2 sine x cos x to the power of 2. So 2 sine x cos x to the power of 2 is 4 sine squared x cos squared x. That is what it is. So 2 times 4 sine squared x cos squared x is 8 sine squared x cos squared x. Then we know this 2 sine A cos A equal sine 2A. So that's what I did. So 2 sine x cos x, sine 2x to the power of 2. And then 2 times sine squared 2x. We know a 1 minus 2 sine squared A equal cos 2A. From that, 2 sine squared A equal 1 minus cos 2A. That is what I'm going to use here. And this one, okay. 2 sine squared x, 2 times sine squared x is 2 times sine squared x, or sine squared 2x is here. 2 sine squared a is 1 minus cos 2x. So that is what I exactly 2 for a is 2x here. So 1 minus cos 4x. That is what they asked us to do. Yeah, that's done. Second part, integral of sine squared cos squared. So we know sine squared cos squared by 8 sine squared cos squared. So instead of 8, they just gave us x squared, sine squared x cos squared x. So I just multiply 8, this one. This is equal 8 sine squared cos squared x. So that is fx, isn't it? So 8. Instead of 8, I just put 1 over 8 and 1 minus cos 4x instead of sine squared cos squared x. Because of 8 sine squared x cos squared x is 1 minus cos 4x. Therefore, I just took 1 over 8, multiply 1 over 8 and put it 1 minus cos 4x inside. So we know simply that integrate that. So 1 over 8, 1 dx, integral of 1 with respect to x, minus 1 over 8, integral of cos 4x. So simply 1 over 8x minus 1 over 8 sine 4x over 4 plus c is the constant, c constant. From that, simplified, 1 over 8x minus 1 over 8 times 4 is 32, 1 over 32, sine 4x plus c. That is the first question done. The second question, the fraction fx is defined by, function fx is defined by fx equal cube root of 27 minus 8x cubed. Jenny uses her scientific calculator to create a table of values for fx and f dash x. So the table Jenny has created is given. Use the calculator to find the expression for f dash x and hence explain why the calculator gives an error for f dash 1.5 when x equal 1.5, f dash is an error. So the table says error. Why is it? So let's see. So fx is cube root of 27 minus 8 x cubed. And I can write that as 27 minus 8x cubed to the power of 1/3. Then f dash x, if you differentiate that, is simply 1/3, 27 minus x cubed. And 27 minus x cubed, differentiation of that So this 1/3, 27 minus 8x cubed to the power of minus 2/3. So it's just function of function method. 1/3 minus 1 is minus 2/3. Time inside the bracket, differentiation inside the bracket. 27 is 0, minus 8x cubed is minus 24x x squared. Then simplified is minus, he took 24 here, so that is 8, that's cancelled out. So minus 8x squared, minus 8x squared inside the bracket, 27 minus 8x cubed to the power of minus 2. Then if you simplify it furthermore, this 8x squared and bring that the power minus to the denominator, 27 minus 8x squared to the power of 2/3. And if you apply this 1.5 for x, so x equal 1.5, x equal 1.5, you substitute that, the denominator becomes 0. So therefore, it's invalid. The denominator is 0. Error on the calculator for the above reason. So it is the denominator is 0, and something divided by 0, infinity. Therefore, the calculator gave her error. Right, next part. Find the next one. Find the first 3 terms of the binomial expression of fx. So fx, we know. Yeah, fx, I just put it in the form of the power rather than cube root. So fx equal 27 minus 8x cubed to the power of 3. Then binomial expansion or binomial property. 1/3 c 0, 27 to the power of 1/3 minus 8x cubed to the power of 0. The first term. Second term, 1/3 c1, 27 to the power of minus 2/3, because of 1/3 minus 1 is minus 2/3 minus 8x cubed to the power of 1. And then third term is 1/3 c2, 27 to the power of 5/3. That is minus 2/3 minus 1 is minus 5/3. Then times minus 8x cubed to the power of 2. So those 3 terms we need to simplify. The first one is 1/3 c0 always is 1. That is 1, what we left with. And then again, 8 minus 8x to the power of 8x cubed to the power of 0. That is anything to the power of 0 is 1. So what we have, 27 1/3 is the first term. Second term, 1/3 factorial divided by 1 factorial and times minus is 1/3 minus 1 is minus 2/3 factorial. And again, 27 to the power of minus 2/3 times 8x cubed to the power of 1 is 8x cubed minus 8x cubed. Third term, 1/3 factorial, 2 factorial. Again, 1/3 minus 2 is minus 5/3 factorial. 27 to the power of minus 5/3 minus 8x cubed squared. So 3 terms. And further simplification, 27 to the power of 1/3 is 3. So 27, we can write it as the 3 times 1/3. That cancelled out, just 3. So that is equal to 3. So 3 first term. The second term, we can write 1/3 factorial as 1/3 time minus 2/3 factorial. So 2/3 factorial, 2/3 factorial cancelled out, only 1/3 left. Time 27 to the 3, that we know that 27 is 2 to the power of 3, 3 cancelled out, and 5 second, sorry, 3 cancelled out, minus 2, 3 to the power of minus 2. Then minus 8x cubed, that is x. Third term can be written as 1/3 time minus 2/3 time minus 5/3 factorial divided by 2 factorial, which is 2 times 1, and minus 5/3 factorial. and 3 to the power of 5, because of 3 to the power of 3, times 3 cancel out, 3 to the power minus 5, minus 8x cubed to the power of 2. Further simplification, first term 3, the second term, we have 1/3, we have minus 3 to the power of minus 2, and minus 8, so that is minus x cubed. Then the third term, we have 1/3, another 1/3. Oh, right, here 2, the 5, 3 factorial, 5, 3 factorial cancel out. These two cancel out. So what we have, 1/3 times minus 1/3, which is minus 1/9, 3 to the power minus 5, minus 8x cubed to the power of 2. More simplification, 3. Then the second term is 3 to the power of 2 is 9. So 1/9, because of power is minus. So they were 1/9. 1/9, another 3, so 1/27. Then minus 8 x cubed. Third term is, if you bring that 3 to the power minus to the denominator, there's 2 here. So 3 to the power 7 times 8 squared minus 8 squared is 64, x to the power of 6. Then, so this 3, first term, second term, minus 8 over 27x cubed, third term, minus 64 over 3 to the power 7 is 87, use a calculator if you want, to the power of 6. So all 3 terms is done. So first 3 terms. Again, I just wanted to use another method, quicker way to do it, because of you probably save time. So the method 2, finding the first 3 terms, fx equal, that's the same, and fx, I just took 27 to the power of 3, 1/3 out. So that will be 1/3 minus 8x cubed over 27 is 1/3. So this part in bracket is like a 1 plus x to the power of n format. That's what I put it here. So let u is minus 8x cubed over 27. Just call it minus, because of, and then n is 1/3. If that's so, that function, we can write these terms. If the actual function become, keep that 27 1/3 separate. So 1 plus u to the power n, because of 1 and minus 8x over 27 is u. So 1 plus u to the power n, n is 1/3, we said. So if that's the case, if it's 1 plus u to the power n, the terms are 1 n times u times n minus 1 over 2 u squared. So these are the 3 terms. So fx, we know right, it's 1 here. We know that 27 over 1/3 is 3. So I just wanted to multiply that. So this 1 first term, so first term here, 3 over, 3 times 1. And the second term, n times u. N times u, n is the 1/3, and we are multiplying by 3 as well, 3 times 1/3. And u is minus 8x cubed over 27. And the third term, you just keep that 3, just multiply by 3, 3 there. N is 1/3, and n minus 1 is minus 2/3 over 2 minus 8x cubed over 27 squared. So simplified, first term, 3. Second term is minus 8x cubed over 27, yes. Third term is here 2 cancel out, 3 cancel out, minus 1/3. So minus 1/3 inside the bracket is minus there squared, so plus. So 8 squared over 27 squared, 8x to the power 6. So simplified, 3 minus 8 over 27x cubed minus 64 over 2187, because of 27 squared, 2787 x to the power 6. So this is more quicker for the exam point of view, this is the good method, and then it's a standard method. We can use it straight. 1 plus u to the power n equal 1 nu, the second term. Third term is n time n minus 2 over 3, and so on. The coefficient of x after third term, right, the second question. Right, expression in binomial first three terms done. Jenny increased the first three terms for the binomial expansion of fx to estimate the value of the integral 1 to 0 or 0 to 1 limits and cube root 27 minus 8x cubed dx. Explain why Jenny's method is valid. In this case, you do not need to evaluate. You don't need to do it, but explain it why her method is correct, or three terms enough rather than the whole thing. The coefficient of x after third term is extremely small. It's just going smaller and smaller and smaller, because if you look at it, 8 over 27 is 64 over 2187, and the next one you can imagine. So it's just extremely small and can be neglected. So therefore, Jenny's approach is correct. So that's a simple explanation for that question, or that part of the question. Right, that is right. Next one. Use the trapezium rule with 4 strips to obtain an estimate of integral 0 to 1, lower limit is 0, upper limit 1, cube root of 27 minus 8x x cubed dx. So it's a trapezium method. Right, okay. Trapezium rule. Okay, just sketch that the curve or graph. Similar that fx, so that is 27 minus 8x cubed to the power 1/3. And 4 strips, so 4 is 0 to 1, therefore 0.25, 0.5, 0.75, and 1. So every strips, the width of the strips is 0.25, 0.25, 0.25, 0.25. So I equal integral 0 to 1, that's what we have to find, cube root of 27 minus 8x cubed dx. Trapezium rule is, I just marked it in that diagram or sketch. The height, y0, y1, y2, y3, y4, and each strip's area is different, a1, a2, a3, a4. Then the height between the distance between the lines, vertical lines, or the width of the strips are 0.25. So that is what it. So simply y0 equal fx when x equals 0. That's what it is. So just y f0 27 to the power of 1, because of when you substitute x equals 0, you only got 27. So 27 to the power of 1/3, that is 3. Y1 is fx when x equal 0.25. So y1 equal f 0.25, 27 minus 8 times 0.25 to the power of 3, 1/3. Then when you use the calculator and you get the value, 2.9954. Y2, fx when x equal 0.5. So x 0.5, y2 equal f 0.5, 27 minus 8 times 0.5 to the power of 3, the whole thing to the power of 1/3. And use the calculator, you get 2.9625. Y3, fx when x equal 0.75. So y3 equal f 0.75, 27 minus 8 times 0.75 to the power of 3, and whole thing to the power of 1/3. Use a calculator, you get 2.8694. Y4, fx when x equal 1. So y4, f1, 27 minus 8 times 1 cubed, 1/3. Then when you use the calculator, that's the value, 2.6684. So the actual integration is the integration, the limit is 0 to 1, the 4 strips area, which is A1, A2, A3, A4. If you add them together, then we get the answer. So, right, The first one, A1, the height we said that, or the width of the strips, we said that H. The trapezium, so if we have, so if you look at it, here we go. So simply it's there. So if you do that, something like that. So this is H. This is Y0, say Y1, and this is so the area A1 equal half time the height, which is H, and the addition of Y0 plus Y1. That is exactly what I did here. So half, instead of half, H over 2, Y0, Y1. H over 2, Y1, Y2, the next strips. H over 2, Y2, Y3. H over 2, right, H over 2. H over 2, Y3, Y4. Right, H over 2 common. We can take it out. H over 2 out. So what we have Y0, Y0. If you look at it, we have Y1. There's another Y1 on the next term. So 2Y1. And then 2Y2, 2Y3. That's only Y4. And substitute all that values which we have found. H is 0.25. And we do all the calculator work. We have the answer is the 2.9154. The calculator, right, okay, so the question. All right, next one, use the trapezium, right, that's we found it. The calculator gives the reading of 2.92117438 for that area or that integration. The graph of y(f(x) is shown, okay. So, yeah. So the question is, explain why the trapezium rule is gives the underestimate, so it's slightly less. Why is it? So, okay, that the 2 point, the calculator reading, 0.9, yeah, 2.9211. 2.9211, and the hour reading calculation is 2.91. So the calculator reading is 2.9211. That's so slightly our reading, our calculation, slightly less than the calculator accurate value. The reason why the calculator reading is there. So the trapezium rule method is an approximation approach or approximation method. But if you want to make it more accurate or more closer to accurate, the strips has to be smaller, and the width of the strips has to be smaller and smaller. The height, I call it, or width, the height of the trapezium would affect the calculation. That is what happened because we only got 4 strips. Therefore, the width is 0.25. If we take 0.1, and then it will be a 10 strip or it's 20 strips. The more and more strips will give us more and more accurate values. The law of the height, the more the accurate the calculation, because the law of the height means the width is smaller and smaller from 0.25, less than that, say 0.1 or 0.05, and so on. So the more, that's why the lower the height, the more the accurate the calculation. Then we can get our calculation is closer to the calculator calculation. That's it. Thank you. Please subscribe to the channel and share the contents with your friends and other A-level students who are taking Oxford and Cambridge. Doesn't matter, Oxford and Cambridge A-level exams. Thank you.